Alright, nothing like starting off a video with a word, so why don't you go ahead and write down Faust. Write down Faust. F-A-U-S-T, Faust. Once you've written down Faust, let's take a look at another way we can describe solution concentration. We can describe it using percent volume volume. Percent volume volume, like percent mass, is the volume of solute over volume of solution. So it's solute over solution. Solute over solution. The only difference is this time, instead of it being a mass of solute, it's a volume of solute. The units are going to be the same. This time it really doesn't matter if it's milliliters, milliliters, it could be liters, liters, as long as the units are the same. Most of the time people really are referring to milliliters, milliliters. Once again, we're talking about solute over solution, not solvent. Once again, we are, in making a solution by volume, we would be measuring out the solute and then diluting to solution volume with solvent. This is like the second time I've mentioned it, and I had 2 slides in the first part of this video over that concept, so I'm hoping you're familiar with it by now. So it's volume, it's percent, solute over solution times 100. Not going to belabor this one. Here in the next slide, we have an example we're wanting to work. A solution is made by dissolving 4.2 milliliters of methanol in enough water to make 25 milliliters of solution. What is the concentration? Well, they've made it easy for us. They've given us the amount of solute. They've told us the solution volume. So 4.20 milliliters of methanol divided by 25 milliliters of solution times 100. 4.20 divided by 25 times 100, and that gives us 16.8% volume. And once again, in literature, when you see that symbol, that VV there, that means it's percent volume. Make sure my decimal point's thick enough there. All right. Chemistry's easy, life is hard. Let's look at the next example. The next example is how many milliliters of ethanol would you use to make 125 milliliters of 11.5% ethanol in water solution? Once again, like the previous example we saw, they've given us a percent. So we know that we have 11.5 milliliters of ethanol for every 100 milliliters of solution we have. We're back at that chemistry cap principle, right? That whenever you hear a per, you have a conversion factor. So 11.5% is a conversion factor to go from ethanol to milliliters of solution. We're wanting to make 125 milliliters of solution. So we would start our line with milliliters of solution, place milliliters of solution where they cancel out. Place milliliters of ethanol, and that's ethanol, where they'd be left. Milliliters of solution is canceled out. We're left with milliliters of ethanol. Multiply everything on top. Divide through by everything on the bottom. And that gives you 14.375 milliliters is your calculator lie. We've got 5 sig figs there, 3 sig figs there. So we're going to be with 3 sig figs, 1, 2, 3, 14.4 milliliters of ethanol. Chemistry is easy, life is hard. Why don't you write down Daunte? Write down Daunte, D-A-U-N-T-E, Daunte. Next. Now we're going to talk about making a solution by dilution. We already talked about that in a great deal on the other slide, but let's actually use some terms for this. Whenever you're making a solution that's percent volume, by definition, you're making a solution by diluting a concentrated solution. A concentrated solution is a solution with a greater concentration of solute compared to the dilute solution. The dilute solution is a solution with lesser concentration in comparison to the concentrated solution. In other words, these are relative terms, just like more or a lot or a few. Dilute and concentrated are used in comparison to other solutions or in comparison to themselves. There's no actual numbers attached with these terms. Dilution is the process of adding solvent to a solute to reduce its concentration. For example, if I have here we'll go back to our model. We've got our volumetric flask, which is a piece of glassware designed to measure 100 milliliters of water. Into this volumetric flask, I put in ten milliliters of a 10% ethanol solution. I then add enough water, why water is red this time, I don't know, to make my total solution volume 100 milliliters. I've taken my concentrated solution, my 10% solution, and by adding water, I've diluted it. I've diluted it to a new concentration that's less. Right now I'll give it the appearance that I've pulled that concentration out of thin air, but I've diluted it to a 1% solution. Let me make sure I've got that right. 10 times 10 divided by 1% solution. I've now made it a 1% solution of ethanol by diluting it. Right? So I've made a dilute solution from my concentrated solution. A lot of what you do in lab will be making dilute solutions. It costs, post office charges by mass to ship things, right? So if you're going to be shipping a liquid chemical, what are you going to do? You're going to ship it in the most concentrated form possible, right? If you go to the grocery store and you buy iced tea, it's cheaper to buy the concentrated stuff, right? Because the shipping's less. So a lot of the solutions you make in lab, you'll be doing a dilution or somebody will have done the dilution for you. So mathematically, what would this formula look like? What did I do in order to do these calculations? Let me clean things up a little bit here. Performing a dilution calculation is really very, very easy. The formula goes like this. The percent of the concentrated solution that you have times the volume of the concentrated solution you have equals the percent of the dilute solution you're going to make times the volume of the dilute solution you made. So in our little scenario here, we had a 10% solution that was concentrated, and we used 10 milliliters of it. We diluted it to a volume. In other words, we made 100 milliliters of our dilute solution. To get percent dilution by itself, I'd have to divide both sides by 100. When I do that, my 100 milliliters cancel out, my milliliters cancel out, and I'm left with milliliters canceling out. 10 times 10 is 100, divided by 100 is 1. So my solution would be 1% ethanol. Gee whiz, we can't make out that formula from your chicken scratch. Here is the formula in a nice, neat, written out fashion. The concentration, that C stands for concentration, of the concentrated times the volume of the concentrated equals the concentration of the dilute solution times the volume of the dilute solution. C stands for concentration. And I should note that I use the word concentration instead of percent on purpose, because we could have used parts per million, parts per billion, or something like that, as opposed to parts per trillion, as opposed to percent, or even units that we have yet to learn, like molarity or molality. Well, not molality, but molarity, there if we had wished. Let's take a look at another example. How would you make 100 milliliters of 12.5% hydrochloric acid solution from a stock solution that is 50% hydrochloric acid? Well, I'm wanting to make 100 milliliters of solution. So that's the volume of my dilute solution that I'm wanting to make. I'm wanting my dilute solution to be 12.5% hydrochloric acid. So that's the concentration of my dilute. I'm given the concentration of my concentrated solution. I just need to solve for what volume of it I'm going to need to make. So plug and chug away. I need to get a better stylus here. All right. Divide both sides by 50 to get your variable alone. Your percents cross out, so you're left with units of milliliters. And that gives you 12.5 divided by 50 times 100, or 25 milliliters is how much you'll need to use. Pretty easy, right? Same thing we were doing last time, same thing we've been doing other times, just a little bit of a twist. Take a look at the next one here. Another example. We've got 25 milliliters of a 33.33% hydrogen peroxide solution, and we're diluting it to a volume of 500 milliliters. What is the concentration of our new solution? So this time they've given us the volume of the concentrated, they've given us the concentration of the concentrated, they've given us the volume of the dilute, and they want to know the concentration of the dilute. So 33.33%, 25 milliliters. And divide both sides by 500 milliliters to get your variable alone. Doing that cancels out your milliliters, and you're left with the concentration of your dilute solution being 33.33 divided by 500 times 25, and that gives you 3 sig figs, it looks like, 16.7%. Chemistry's easy, life is hard. Why don't you write down Chaucer? Everybody write down Chaucer. Once you've written down Chaucer, we'll move on to the next example here. Actually, we're at a good stopping point, so that's all I'm writing for now. Beep.